love the recordings, to be quite honest. Oh, they did second derivative test today. It was so cute. I know, right? All right. You have probably seen that I de-hoarded some papers. So I had a paper hoard that I got rid of. How's everyone doing today? Long time no see. I almost don't recognize some of you.
My fire alarm went off at 2 a.m.
No, that's the worst. All right, so we are going to be doing some stuff today. Yeah, Sean.
Can I turn this in behind me?
Yeah, just throw. There's already a pile on the middle table. You can just throw it in there. I guess. Where's? He's always here. That's weird. All right. So we are going to be doing some new notes today. Those are on integration by parts. If you've heard me or another student reference OOVDO, we're finally learning that today. It's very formula based with a couple of choices on the front end, a little bit similar to USEB. So we're going to actually do the first two questions of this to get our brains a little warmed up with just calculus in general. Then you guys owe me the latter half of the notes check that we started last time. What I did with those, I collected them last time, but what I did with them is I just checked off any problems that were already correct. And if you had a pretty obvious mistake as I was going through, I tried to circle to give you an idea of where to start fixing. Some of you just didn't get to some of the problems, which was my bad. I didn't give you enough time. So we're going to try to finish that one after we start these notes. And then hopefully we'll get to the end of these notes and do the notes check on this as well. That's what my other class got done. And usually you guys run a little bit faster than they do because there's less of you.
I'm going to be more abstract than the other one.
More abstract. What does that mean?
I have no idea. I just don't.
Oh, then I don't know how to answer your
Not
question.
abstract. Was it complex? Is that the word?
Oh, there is no context in this. No, it says integrate this, and then you do. And Jillian's gone. No. All right. I hear you ran fast yesterday.
Yeah, I know.
Congrats. Looks like everyone ran fast.
Yeah, I know. It's crazy.
I was really surprised that when the early dismissal came through, 6 of the runners came from my second class because I had James and Austin. I have both of San Juliano, so only one of them went. Caitlin, Liza, one more person I guess. Oh, yeah, Nicole. I was running through the table, so I didn't go back to her. All right. So, do you guys want to do a number talk or anything? All right. I had one up because my AB class was being quiet and I didn't know what to say to them. Oh, a reminder to anyone that wasn't here last time, don't be scared. I'm going to start recording all of the lessons from now on. So I hopefully just remind me at the beginning of class. So I forgot my AB class today. So those are going up on a link on our Schoology page. So if you ever need the class video, whether you're absent or whether you just want to go and revisit the lesson, those are up. And I've been doing a pretty good job at getting them up by the end of the day. And I'm trying to keep them really organized. It is just a recording of class. So if you're absent, you can log into class. Someone did that during my AB class today. The meet code is Math with Hefty, or there's just a link on our page. I won't be monitoring the chat. So if you do log in, it's kind of just an observe but not participate. But if you want to revisit the class videos, I'm trying to get those up by the end of the class day. Hopefully that's helpful. If it is really helpful, let me know because I can do it in future years, but it just takes a few clicks to make sure that I do it. Other reminders, if you are interested in reassessing the Unit 4 test, I know Snow has made the due dates a little bit weird. My goal was to get those done by Friday if you need to reassess. But if we're in conversation, we can make an alternate due date if that's a little bit of a struggle to get that done for you. I will have the test made and kind of printed out hopefully by the end of today. So if you're interested, just keep me in the loop as to when you would like to get that done. Also, we are approaching the end of the second quarter, which feels crazy. So start looking at your student view. If you're missing some assignments, especially big ones like quizzes or tests, please start talking to me. I don't want to get to the last week of the quarter and have you be stressed out, because the end of the quarter is always stressful anyway. All right. I think you're going to like today's notes minus one of the questions. So, oh yeah, number talk. Thank you, Matt. There you go. How many passengers can ride in the elevator?
655.
I would say 3 across. And not across. And then there's 4 of the road. And then that one's like 5 or 12. So like 15.
25.
Or how many are comfortable? Fit many more than
Okay, it's either 18 or 626.
I want 650.
You have your answer?
Oh,
Oh,
man. I
man.
love the loose bracelet.
Alright, what am I
17.
35.
Nina, 17. Who said 21?
30.
Who said 21? Nazi. Why did I say that? What? Oh, first try.
35.
No. 30.
I don't know. I was gonna say 656, but.
Wow.
35 Ethiopian children. Sorry, 25. Like 6 Americans.
27.
18.
Well, why do you go back?
Is there star?
25.
Why are they? I said
12.
Hey,
we had Yeah.
28.
It's like, it's 27, you already feel like 30.
It's hard because the angle's like, yeah.
Alright, Elena. Alright, Victoria. 10. 8. Right? Is that 10?
Yeah.
Okay. Adam.
30.
No.
Yeah. 27.
57.
27.
Sean.
I think 17.
Alright. And
15.
alright, I got
Number between 35.
Yeah. I want, no, a number that's probably definitely wrong.
35. 36. 656.
All right. Shall we reveal?
It's the one I got. They already know. Wait! Wait, did I? Rashad? Let's go!
Okay.
First up was the year.
All right.
35 Ethiopian children.
What? 5,000 pounds weight. So how much do they think each passenger weighs? Would that be 5,000 divided by 33?
You're the math teacher.
I just making sure. Sometimes I'm dumb. 150? That's not a very heavy person.
That's like 3 Ethiopian children.
No, I'm really bad at math sometimes. I'm not very creative. I'm not a very creative math person. No, last year, actually, this is a good story. Last year, Dr. Luttrell wanted me and Miss Shetty to figure out, with all of the distance requirements, how many people we could fit at graduation at the stadium. And I was like, whoa, that's like way too creative a math problem for me. So I got Aiden Freeze and Masil Shaw out to the stadium with me so we could measure together because I was like, I need assistance. We all ended up doing our own calculations and then comparing at the end. And then they changed all the requirements, so we didn't need any of that. It was a fun exercise. It was a real life number talk. The most high stakes number talk ever. All right, so we are going to do the first two problems of these notes. Then we're going to pause and go back to the notes check we did last time with 6.1. I know some of you weren't here. I will get you those notes checks so that you can start working on them. There are definitely a couple of problems that you can do. So I want to do these first just to warm ourselves up with calculus because those note sections last time were a little challenging. So let's just get our brains warm with calculus, even though it's not the same calculus. Now, integration by parts is going to be a method that you're going to like very much. Usually every year, people like this method. It's pretty formula based. And as long as you're pretty organized and make the correct choices, it's a pretty easy method to work with. So let's talk about, first of all, what this method is, and then what this method kind of does for us. So I'm going to write down the rule. It's not going to make a whole lot of sense right now, so just kind of trust me for a second. Don't get mad at me until I've done like at least one full problem. You know, people get mad at me a whole heck of a lot because I ask them to learn things. All right. So I'm going to write down a rule. It's not going to make a whole lot of sense until I do a problem. So kind of like when we first learned U-sub, if I was your AB teacher, or if you first learned U-sub again this year, whatever, it kind of doesn't make sense until you do a full problem. So give me a second. We are going to be talking about two functions together. Most textbooks use the letters U and V. Now, if you are a person that doesn't do tails on your U's, I would either start or maybe use different letters. These are just the ones that get generally used in textbooks. So we're going to look at a integrand that's going to look like, let me remember which way it is. So U times dV. We're going to be choosing mostly what the U is. That's going to be the big choice that we're going to talk about today. What do we choose as U? Kind of with U-sub. But we will have to identify what dV is as well. If we integrate this, it's uv minus the integral of v du. Ooh, voodoo. Now, I thought that was the stupidest thing the first time my students said it. I said, please stop, please stop, please stop. But then they remembered it better than any year that I had taught it before. So if you get to college, this method is called integration by parts, but for right now, you can call it OOV-VADOO. Now, what does this method do? What does this dot mean? Multiplication. What's the answer to a multiplication problem called? A product. So this, just like U substitution, is kind of a reverse of chain rule. This is kind of a reverse of product rule. So you're going to notice a lot of our integrands today are going to look like products. I mentioned that because on the unit, whatever unit we are in, unit 6 test, I'm not going to like put down, do this one with integration by parts, do this one with partial fractions, do this one with U-sub. You're going to have to make those choices. So this in general is a really good method. If your integrand looks like if you were taking the derivative of it, you would need product rule. So it's definitely, the idea is we're reversing product rule. I do want to show you with not great notation where this comes from product rule wise. So let's say I took the derivative of U times V, the product. How does product rule go again? First times derivative, second plus second times derivative first, right? So U, I'm going to call the derivative of V dV plus V derivative of U du. Let's say I slap some integrals on this. Integral of a derivative, I'm just going to call UV. And I have these integrals here. Notice if I subtract this to the other side, that's where this formula is coming from. So excuse my not great notation, but I do want you to notice that these terms are coming from the product rule. So we're kind of reversing that process. So that being said, we're really going to treat this very much like a formula to help us put these things in our places. So once we make the choice to do integration by parts, the big choice after that is what do we choose for U? We're going to make some guesses at the beginning, but by the end of today, we're going to have a very defined set of kind of functions that we choose in a specific order. So does everyone agree that this looks like a product in our integral? We've got x and we've got e to the x. Both of those things have x's in them and they are being multiplied together. We can't just integrate them separately, so we've got to pick some stuff out. Does anyone have a first guess of what you think I'm going to call u? That is actually not what I'm going to choose, but you have no idea yet. So let's just try x because I know it's going to work. And we'll talk about it, why I'm choosing this. No, I'm actually choosing this x right here, if that's not clear. Okay, so actually, I'm glad we talked about that. I'm choosing that x right there. It's going to become obvious why I'm doing that. So we're not choosing the u based on like function inside another function, like you said. We'll talk about why we're doing this. Yeah. Yeah, so Rashad's answering the question that I was asking in my brain. Wow, glad that telepathy is working now. What's happening? Are we doing a gallery walk?
It's a math journey.
Do you guys want to do a gallery walk?
Yes.
I've tried to do gallery walks in BC before, and people just get up, take pictures of all of them, and sit back down.
I like what we did that one time where we did the scavenger hunt.
Yeah, that's a lot of work. It's a lot of work, man. All right. So the question that I was going to ask that Rashad answered without knowing I was going to ask it is we need to figure out what dv is. So unlike in USub where we just choose u and kind of roll with just that choice, dv is going to be everything else in the integral. So since I chose this x to be u, dv is going to be e to the x dx. And I want to do all that stuff. Kind of. We're going to find du in a second, actually. So once you choose u, just everything else is dv. Now, Nazi is also kind of reading my mind because we do need to find du. That's part of my formula here that I'm going to need. Another thing I need is v. That's also part of my formula. So one thing that makes this method a little bit hard is how do you think I'm going to find du, du from u? I'm going to take a derivative just like normal. So what do you think du is? 1 with the dx. So that's just normal, regular kind of use of stuff. How do you think I'm going to get from dv to v? Integrate. So that's what makes this method a little bit tricky. We're going to be working with derivatives and integrals kind of at the same time within an integral problem. So there's a lot happening, very predictable, very methodical. So what is the integral of e to the x? Okay. I will say it pays to be very organized in this case because the next step that I'm going to do is I'm going to plug into what is effectively our formula, our uv minus the integral of dvu. If you don't have to guess where all of that is coming from, if you can kind of just pick up the pieces, a lot easier. So I'm going to do uv, that is x times e to the x. That will not always match the integrand, it just happens to here. Minus the integral of v, which is e to the x, du dx. So I'm very much just grabbing the pieces from my organizational work down there. Ashley. Oh, sorry, that is a U. This guy? Yeah. Apologies. All right, any other questions before we get talking? All right, one thing that may happen, sometimes, usually, this second integral that we have here, that's our v du, do you agree that this looks better than the original integral did? So it may look better in the sense of it is more easily integrated. It might not look smaller. We'll see that in the second question. But theoretically, this should look like we're making progress towards something. This is a method where if we choose the wrong view, we're going to make it worse. So we're going to get to the point where the choices really matter. If we do things wrong, we're not going to be able to do the problem. So you kind of do want to investigate whether you're doing these things right. All right, so our first term, that x e to the x, he's already done. He's already integrated, but we still have something to do. Do you guys know what the integral of e to the x is? All right, so I'm going to integrate this second part here. So this guy right here is going to get integrated into e to the x. And now I'm finished integrating, right? Excellent, you read my mind. Plus c, and we are done. So very exciting. We've just integrated something that we could not integrate before. So why did we choose integration by parts? Our integrand looked like a product. Now, what made this view kind of beneficial? Anyone think they could put into words why x was a good choice for you? Yeah, it's simplified. When I took the derivative, that x kind of went away. So polynomial stuff can be a very good choice for you because as I take a derivative, that power is going to go down, eventually turning into a constant. Now, would it be annoying if I started with like x to the fifth? Heck yeah, it would. But an x would be a really great choice. Shall we try one more? All right, what do you think I should choose for you? Let's try it. All right, if I choose u equals x squared, what is dv? What's dv? Yeah, the rest, natural log of x dx. All right, now the question that you wanted to answer, what's du? 2x dx. All right, how do I find v again from dv? Integrate. What's the integral of natural log of x? That's the derivative of natural log of x. What's the integral? We're actually going to do this later today. You need integration by parts to find this integral. So one thing that I did set you up for failure. You guys read my mind. All right. We do not know. Ooh, that's bad. We do not know what the integral of natural log of x is. We just don't know it off the top of our head. So while polynomial stuff like x's or x squareds are great choices for you, they're not our first choice. Our first choice is anything we don't know how to integrate. There's two major examples, so I'm going to start writing some notes here. Things we can't integrate. That has to be our first choice for you. So logs are our first example, usually natural logs, but I could do like log base 2 if I were being really mean. The other big one, arctrig. We don't know what the integral of like arctangent is. We learned last class how to integrate into arctangent, but we don't know how to integrate that thing in particular. So the reason we choose those things for you is they can't be our dv because we don't know how to integrate them. The next good choice for you is what we did in the first problem. So I'm going to call it, kind of going off of what Nate said, things that go away. These are how I think of them. So if you don't like these words, that's fine. But that's essentially like polynomial things. Usually you might see an x or an x squared. We'll talk about why x cubed or x to the fourth would not be probably what something would be. But those are generally good choices as well, kind of in that order though. So I like doing this question towards the beginning because it really emphasizes the point that if we choose wrong, we can't do the problem. I think this is one of the most exciting parts about calculus is that our choices matter, in that if we choose wrong, the problem doesn't work. I kind of don't like in algebra 2 that you can like make any choice and make it work for yourself. There should be consequences to choosing wrong. But it starts teaching us a very valuable skill of like, if something's not working, the ability to stop and try something else. That's a very valuable math skill. So if you notice that things aren't working correctly, but you're convinced you still want to use integration by parts, because this does look like a product, let's try swapping out what we said U and DD were. All right, thoughts on U if it's not x squared? Natural log of x, which means dv is what? All right. What is du, the derivative of u? Okay. And then v? How do we find v again? Integrate, so one, yep. Again, just very focused on the specific parts that we're doing. Don't try to do too many steps at once because there's a lot of different steps. None of them are particularly super difficult, but there's a lot of things happening. Oh, that's a good note. I'm actually not going to do plus c's on the v's. I didn't hit that before, kind of because we're inside an integral. So I'm going to only throw that plus c on at the very end. I didn't mention that before though, so thank you, Rashad, for mentioning that. All right, so let's come over here and I'm going to do, how does this go? U v, is it plus or minus? Thank you. The integral of v du. Kind of like back when you first started, what is it called? U substitution. I'd encourage you to kind of just plop everything where it goes and not really simplify as you're going, just to really keep track of your steps at the beginning. But once you start to get comfortable, put things in places where they're helpful to you. Kind of going to come down here. Now, does this look better? Kind of. It looks bigger, I would definitely say. I do kind of lose the natural log, which makes it look a little bit less scary. Because can anyone think of a way that we might be able to simplify this? Ah, okay. I'm looking at this part right here. Nate chucked an x squared at my face. Do you guys see where he's getting the x squared? Okay. Yeah, I could do 3x's divided by 1x, cancel one of those x's, and I get x squared. So while I cannot integrate the product there, I can simplify it to get something that I can integrate. So that's what I mean by better. Like, this doesn't necessarily look nicer, but it does look more integrable. So I'm going to go ahead and copy down this first term, u after today. Are you guys cool if I bring this 1/3 out in front of the integral? Yeah, could I do that if it were like the 1 over x? No, only numbers. All right, and do we agree with Nate that x cubed times 1 over x is just x squared? If you don't, then here's how we do it in Algebra 1. X cubed is 3x's. 1 over x, here's over 1, and you can cancel one of them. Yeah, in Algebra 1, we write all of them out, even if it's like x to the 15th. It's my favorite unit. We're my least favorite unit right now. Inequalities. Wait. Do you remember when to flip the sign? It's the worst. Nice. All right. Personally, for me, I like rewriting some of these, so you're going to see me do some simplifying. One thing I cannot do, and let me make sure we make this very clear, can I combine that x in the natural log of x with the 1/3 x cubed? No, I'm getting some very strong shakes of the head from the back. So personally for me, and this goes with most of the multiple choice answers I've seen as well, I like writing these in the front like this. That's a preference thing though. Write it wherever you want, as long as you don't combine it with the x and the natural log of x. And then let's integrate this guy right here. We've got x squared. Oh, we already did that. That's 1/3 x cubed. So 1/9 x cubed, or x to the third over 9. Sorry, let me do it in 2 steps. Shouldn't skip steps. Apologies. Do you agree that integral of x squared is 1/3 x cubed? No. Well, what do I have to write though? So do I have to write it like that is a really good question. So on a free response, write it however you want. This question would probably be on a multiple choice. If I had to predict what the multiple choice answer would look like, I would probably predict that they would at least simplify this fraction to a 9th x cubed, or maybe x cubed over 9. These usually provide a decent way to factor too. So get it, like I could factor the x cubed out of both of these terms, maybe factor out a 1/3, something like that. So this is a good example of get it to where you're comfortable and then start matching with answer choices and seeing where you can match. So wherever my test will probably be mostly free response. So kind of get it to where you're comfortable, and then algebra skills will take you further. All right, so I want to pause right there. How are we feeling about integration by parts so far? Feeling great? Cool. When we get back, we're going to answer some other questions. What do you do with bounds? This will be a different question that you won't like the answer to. You're going to try this one. We're going to skip this one. And then I'm going to show you a shortcut method for the one that you're not going to like. So if you like integration by parts a lot, I may make a video on this one, or it's a cool thing to look up. This question is like one of my favorite calculus questions of all time. It's a very cool, tricky thing to do, but only like maybe a quarter of you will think it's exciting. So probably skip it today. So I am going to hand you guys back some notes checks right now for 6.1, which were all of those like weird transcendental functions. If you were not here last time, I can throw the notes check your way. I would encourage you to try to get at least number 4 done if you were not here last time. We're probably going to work for about 10 minutes on this, and then we'll continue with the notes. Hopefully that will be enough time for you to get done if you weren't here last time. That might not be enough time. So no worries on that part. Again, if you started work on this last time, I gave you a check mark if your question was right, but I have not graded this yet. So you still will get this submission and one more submission, if that makes sense. Okay. So if you have 2 done, you have 2 to do. No.
Yeah.
Oh, use it.
No, it's not here.
There's no handle on it.
I know, I need to do it. The handle's like over here. It doesn't stay on.
It's like, yeah, it's like okay.
I think that part of it got, what do the kids call it? It happens, those big questions. See,
I tried to do it.
I fixed it for a while, but then people like.
It doesn't work. The blades are gone. I'm telling you. I completely forgot how to do it.
Cheap Chinese blades, yeah.
It's true. The cheap Chinese
They
blades.
were made by Elon. That's why.
Yeah. And Elon Musk cobalt mines. It just doesn't work. I tried so many times. You show me yours too.
Yeah. Mine like,
See, this doesn't work. It's a scam. It doesn't work.
I get it.
Sean, can you sharpen my pencil? We'll see. Let's see. I'm putting it here. I have no idea.
I don't like
This is sharpened. You gotta peel off. You have to peel off the other part of the pencil.
Oh, yeah.
Who's on a professional pencil sharpener?
All right.
I should probably this one kind
Let's be positive.
Yeah.
I don't.
Yeah.
Which question?
I will look at the front of the 16 where all the rules are, like mascot.
All right, my goal is to be done. Most of you have like 2 questions to do. So my goal is to be done those in 10 minutes. Let's see how we're doing.
Oh, the one.
I got it before it was cool. Now it's cool. I haven't seen the first one. Good. One, so you got it in the grad class, so then-
They are.
No, and all of the regular, like the rules.
So then when I put the two on top. Oh, I see what you did there.
Oh, it was like,
We're only allowed to add 0. We're not allowed to if I added 4, I also have to subtract 4, so I said everybody has to. Also, we're adding 1 I just have to.
This one, I mean, you sub or you just.
Oh, so you do, that one's theoretically, you can do.
Oh, yeah, that's that over and up 6 times 6. Oh, then that's okay. Oh. Yeah, oh, no, I didn't do that.
Yeah, that was a good
The one, yeah.
One thing we're gonna, so there will be questions on the type of like. One of the big things we're doing is trying to figure out. Over.
No.
So is the
Oh, yes, that. Yeah, question. Did I? Okay, so that's one.
Oh,
Yes, yeah.
Wait, do I do this?
If you want to, or is that it? If you want to.
Which one will give you this one?
That or if you simplify.
How do you simplify? This is one.
Okay.
So it's just.
Oh, this is it.
Over.
Oh.
Minus.
Yeah, you can go one step further if you wanted to.
Oh, 5. What?
Oh, I'm gonna grade them in a second. All right, if you happen to get done before the 10 minutes.
Your problem set's feeling lonely.
No. I don't think so. Well, you're using the rule of for the actual, not minus 1.
I was like, what?
So then I'll be number 2.
Like, so it's like, you add here,
That's a good song. That's a good song.
Yeah, I'm just so mad. He was so mad with me as well.
We added 4 and subtracted 4.
I know, I don't actually. I know the. Oh, I can't. Oh, I'm not.
Yeah, and the whole point is that it comes back.
Now is it right?
Yeah.
Which one should I look at for number two? I'm not sure.
It's easier than any of the problems that are on there.
Did I say dependent?
I did. Is this right? For what?
You don't have to do it.
Yeah. You get like a second view.
So, step 5 would take you in the middle term, my mind is correct.
I was prepared by that.
Negative 2 squared. I don't know.
Okay, so I also said I don't know. And then I gave you
What are you doing here? You did the same thing Ruth did in my life when you did.
But this is right.
No, it's not.
What is
See how there's a check mark at that last step and I don't remember?
What did I do wrong?
What thing has an integral or a derivative that looks
I
like
knew that
whatever
didn't seem
you
right.
do?
Yeah, it seemed right to me.
That's not right. Why are you plugging me back in? How about the integral? What's the integral of that? You could also write that 1 over e.
No.
It's on. It's one of the ones you have to know too.
I didn't say it. He was aware.
One try.
That seems like, yeah.
Oh, I can use my training. Maybe go through like a 15-minute training.
To make it training.
It's like special, like, here. All of these are like,
I don't know how I made
But what's the problem? What funny?
no, every year we go through a bunch of like, I learned
Have you ever used that one?
how to. In college, yeah. Yeah.
This one?
Yeah.
Do I plug in a zero? Calculator?
No.
Oh, we're
I
supposed to
just need it with
have
an apple.
Oh.
Give me a pause.
It's gonna go over. It's gonna go over. Yeah. You look at Jay's winter though. I can't help it. I don't know.
Those ones were, some of those were the optional ones, if you don't want to. Correct.
It's chapter 5, the one where we have to do both.
Yeah. So,
Yeah, that-
you want to do that, be 100%, if you want to do the extra. Yeah, that's what I would give you the extra. I love that video.
I'm pretty sure I did that wrong.
Literally,
We got canceled.
they don't use plastic. Yeah. Hello. All right, can I have pause? Let's go. How many people are all the way done with their 6.2 inertia? All the way down, it's turned in, they're done. All right, that's a lot of people. Sorry, not 6.2, 6.1, 6.1. I haven't given you the 6.2 one yet. All right, if you still need time, how many more minutes? You can use minutes on one hand. Not if you weren't here last time. You don't count. All right, let's just go. Let's just do 5 more. That's fine. And then we're gonna do more integration by parts, sir.
Oh, true.
So 5 more minutes. If you are already done, get a problem done. May I suggest? Number 2, it's easy. Number 1, relatively easy. 5, surprisingly easy.
Is it like 6.1?
All of up through number 5 is 6.1 or 80.
So where does the,
Oh, yeah.
do I?
I know, I haven't even put it in.
4 and 9.
Yeah, so I did number 1 again, but I got into the fancy.
Okay, so for you, the problem with the U substitution in this case, if you want to think of the U that would get you, here. So you don't want your U to be 16 because 16 squared. What number is squared? 4. So then you have to be 4. That's like the top bar.
No, it's 6.
No, it's so good.
One
No,
time
it's
that.
such a bad but like, I was like, really funny. Like, that is such a good song.
That's the hard part. You know what I need to do. That's the hard part. I don't want to rob you of trying to make that decision because that's the hard part.
So be brave and try something because the value thing of choosing, knowing when you're choosing right and knowing when you're choosing wrong, that's the thing. You really are struggling. Try not to get frustrated. Yep.
Are you taking those?
Yeah.
It's hard, but you're also. You're helping me.
No variety.
I don't like, yeah, true.
Okay, bye. That's why I love because someone like you, this past week, just got yellow. But that's why I I have two of these, I don't know which one it is. Oh, it's. Oh, it's my show. Yeah, my brother. I think like growing
I'm trying to remember if I like that.
Yeah, well, like, my favorite. All those people.
Hold on, I'll be fine. I have it memorized.
Well, oh, yeah.
Oh, yeah. We just did our steps down. Oh, I want you to check the floor. If you maybe check the.
Yeah, but I just don't know.
I would argue, you might be getting to the point where what fraction we're gonna get. That's in my head. Are you? I can
Oh, this is
Oh my god.
I like your dance move.
Thanks. All right. I would like you to get to a good stopping point for now. If your notes check is not done, we may have a little bit of time at the end of class today. If you're one of the people that wasn't here last time, maybe hold on to that until next time. Your grade book might look a little weird, but I'd rather you take the time to finish it if you'd like. What we're going to do in a second, I would like to do 2 more problems myself and then have you do one. We'll see if we can go. Are we brave enough without a break today? Or are we gonna need a break? All right, let's reevaluate after we do this problem. I would like to at least do this one because I think this is probably the hardest question on the notes. Doesn't it look simple? All right, so let's talk about integration by parts for this one. So a couple of things we're going to notice in this one. 1, how to deal with bounds. And then 2, does this one look like a product? No, but it is integrating something that we don't know how to integrate yet. So integration by parts, a good fallback method if you just have nothing else to work with. So like arctangent here, and as you saw, natural log of x, you guys are going to try this one because it's relatively easy. This also a good method to try if we've got like no other ideas. So the question of how to deal with bounds, the best answer is just like really don't until the very end. So I'll show you how to notate it, but usually with me, when I do these questions with bounds, I integrate it all the way pretending the bounds aren't there, and then slap the bounds on at the very end, making sure not to set those two things equal. All right. Our first choice. What do you think U is? Yeah, I don't know how to find the integral of arctangent of x. If I did, I would just integrate it, and then we'd be done. So, it can be. A lot of the, usually the ones you're going to see, Nina, are like the ones on the front page. Usually the ones we're going to see most of the time will be a product of two things. This one is an interesting integral. I will say this one's probably a little bit harder than what I would ask you to do on an assessment. But a lot of valuable integration happens in this, and I want to teach you how to do that. So I would say of the methods that we're doing, the other ones that we'll do after today have very specific situations. So if you have something that you're just like, I don't really know what to do. Like, I don't know what to do for arctangent. I got nothing else. Integration by parts is a good fallback method in like the grand scheme of integrating. The thing we're going to do next time, partial fractions, it does not apply in this situation because I need a fraction. So it's my favorite method. It's the first lesson I ever taught, ever. Partial fractions. It's so fun. It's so much algebra, like so much easy algebra. So great. All right. So if we choose arctangent x as our u, what is dv? dx. That's all we got left. All right. Who wants brownie points? Who knows the derivative of arctangent x? All right, I like how you guys are saying the A thing, that's fine. It does look like the question we were just doing on our notes check. Since this is just x as the argument for arctangent x, or like x over 1, that A that you guys are talking about would be 1. I get v by integrating, so what is the integral of dx? X. Y'all should just wait until Emery answers and then just say what he says. Way to go, Emery. All right, so I'm going to show you how you would have to notate here. It's going to be a little annoying, to be quite honest. So I probably would not write what I'm about to write. I'll show you what I would actually do, but I want to show you how you would have to notate this if you are going to use the bounds in every step. So how does the formula work for integration by parts again? Oov, okay, oov. Arctangent of x is u. V is x. Could I make these two x's into x squared? No. One's an argument for arctangent, one's just a lonely x by himself. So in the next step, I'm going to probably pop that x out front. Plus or minus? Thank you. Integral of vx du. 1 over x squared dx. Now, I will say what I have just written down right now, this causes issues. The right-hand side right now, the fact that I do not have bounds on this would produce a function, whereas with bounds, this would produce a number. I'm not allowed to just set those equal to each other. The problem is if I stick bounds right here, which I need to, I still haven't quite remedied the issue because I have part of this that I've already integrated. Anyone remember what the notation was for like, hey, I've integrated, but hey, I haven't plugged in the bound? That straight line. So if I really did want all of this notation, I'd have to represent the bounds two different ways within my problem. I personally, and most people who do this in textbooks as well, or do problems as teachers, whatever, find that notation a little bit overwhelming and a little bit, I don't know, it's just annoying. So what you'll see me do most of the time is actually just forget the bounds exist at all, kind of just find my whole integral, and then at the very end in a separate step, plug in my bounds. So I'm going to kind of just pretend the bounds aren't there and then go from here. We changed the bounds for USUB, but here we don't have to. We do not. So I'm gonna take this guy and I'm gonna kind of pop him down, simplifying a little bit without bounds. So I'm gonna take the X out front so I'm not tempted to make that X squared inside our tangent. Yeah, so this is without bounds.
So are you saying that in the future you're not going to make those bounds?
I probably won't unless there's a situation that needs it. We'll see what it does at the beginning of next class. We're going to do like an AP style question. So most of the time, if I can integrate and find an actual function at the end, I will just kind of ignore the bounds. All right. I think I'm going to pop, see that X times the fraction. I think I'm going to pop that X on the top. All right. Well, this second integral, looking spicy. There's some stuff in here. Any thoughts on how to do this question? You said? What do you think you should be? Okay. Let's try it. What does that make du? 2x dx. Is this going to work? Let's see. I've got the x dx I see. Can I move the 2? Yeah, perfect. So one of the hardest parts of this unit, I was kind of talking to some people as I walked around helping people with the problem set, the notes set. The hardest part of this unit is making the choices. And I want you guys to be brave. You have to make a choice. And one of the most valuable things for math in general is to be able to make a choice, know when that choice is right and it's working, know when that choice is wrong, and you have to make a new choice. I don't mind if I see you choosing 10 different methods on the test, as long as you know when to abandon it and choose a new method. You can be wrong. You just have to know when to stop being wrong and try to be right. So if I still had the bounds on, I would change the bounds here. I'm kind of ignoring the bounds right now. So I'm going to keep my first term. He's just hanging out for the party. And I will substitute here. I'm going to put my 1/2 out front, my du at the back. So that's going in for the yellow stuff, the x dx. What's my integrand going to look like? 1 over u. Oh, that looks familiar. What is that? Natural log of absolute value of u, right? And I'm going to plug u back in. You guys giggling about it. So we don't have bounds on right now.
No, but would it apply to that?
No. So I'd have to use the original bounds in person. So Chris is asking some good questions about bounds at the front. Another reason I don't really want to mess with bounds in this case, if we were doing USUB and we changed the bounds on the second part of the integral, we would have 2 different sets of bounds because we'd have the u bounds and the x bounds for the x arctangent of x. So we're really benefiting with kind of just ignoring those for a second, and I'm about to put them on at the end. I also want to throw out there, some of you may be getting pretty good at USUB, so I want to give you some of you permission to kind of skip some steps. If you're starting to get to the point where you're like, I see that this is the derivative of this, and this is just going to chuck a 1/2 out in front, there are instances where it's a little bit easier than others, but if you can go straight from this to this, I can also do that. So if you're comfortable going there and you want to start doing that, I'm okay with that, especially for some of these where it's just going to chuck a constant out in front. I just want to give some of you, if you're feeling great about it, giving you permission to start skipping some steps. If you're not feeling great about it, that's totally okay. If you want to write out all your USUB steps every single time, also totally okay. Nazi. So the first part is integrated already. So that term is always just going to kind of hang out at the front while we work the back end. So it's almost, someone in my other class kind of mentioned it almost feels like there's two separate problems. You kind of start the integration by parts and then you got to work the second end. All right, so let's throw these bounds back on and then maybe we'll take a break because the bounds aren't going to be super fun. So return of bounds. I am going to take X. I'm just going to be really explainy about how I'm plugging this in. All right, so I'm throwing, what were my bounds? 0 and 1. All right, just because a bunch of you weirded this up on your notes check, which bound goes in first? The top one. Ah, am I allowed to drop them? Yeah, 1 plus x squared is always positive. Not if you don't want to. As long as you know that thing is always positive. All right, so I'm going to do 1 times arctangent of 1. Yeah. All right, this is a value you should know, but I'm going to translate it for you. My other class was asking me to make a list of values they should know, so this would be on it. So arctangent of 1, or tangent inverse, that little -1 of 1, I'm asking you at what angle is tangent 1? Yeah, pi over 4, that works. Of course, sine and cosine are the same, so sine over cosine would give you 1. Minus 1/2 natural log of 1 plus 1 squared, so natural log of 2. All right. 0. 0 times anything is just 0. So I don't really care in this case what arctangent of 0 is, but let's just talk about it. For this one, yeah. Does anyone know tangent of what equals 0? It doesn't matter, but this is one you should know. Just 0. It's here because sine is 0. You've got sine over cosine, so 0 over 1. All right, then you got minus 1/2 natural log of 1 plus 0 squared natural log of 1. Anyone know what natural log of 1 is? Good, 0. So this whole back end is just 0, and we get the beautiful final answer of pi over 4 minus natural log of 2 all over 2. So when I'm evaluating arctangent, since that's the inverse of tangent, a really good way to think about it is if I have arctangent of 1 equals something, that's asking tangent of what angle equals 1. So it's an easy way to think about it. Easy being a relative term there. Okay, is this my favorite number? No. Am I going to simplify it? No, because I don't have a calculator. All right, break? Good. Yeah, that was definitely the hardest question. And I will say, this is probably like, not probably, definitely like bonus level on a test. This is a little aggressive. The next question would be definitely fair game. So, probably not right now. Maybe. Probably not though. So when I make the test, my thoughts of, let me put the timer on. When I make the test, my thoughts are trying to test you on the methods that we're learning and not necessarily like algebra skills or pre-cal skills. So I wouldn't want to take like a full point away on a 5-point question because you can't evaluate ArcTrig. On the AP test, remember, I could technically leave ArcTan 1 in my answer. So you can get a little lazy about it. Just for the sake of multiple choice, though, we'll evaluate them on the notes. And say the first 2 are more so like test level questions. Maybe putting like some u sub in the e to the x or like something like that. Yes, perfect.
I saw that. Who's going to pay $500 to have a full page of them?
What are you talking about? Oh, the yearbook? my parents never did anything like that.
Spotlight, like talk about needing attention. Like, how amazing are you that you need a full plate?
You're also supporting the school though, so that's kind of nice.
What, you better have like done something pretty awesome.
It's just like a big picture of you and my son.
Like if you're just like some like, you know,
My
average
parents
student.
were like, so we're not getting you any of those things. They're like, hopefully you still know it.
This week, I think no. I think because of all the snow days, teachers freak out a little bit when we lose a lot of instructional time. I did not personally complain, but Wellness Wednesday is also not my favorite thing. A lot of people don't want to do it. So I usually end up with an activity that's like lower stress. So I think I'm doing like trivia or something. So you end up with people in the room who like don't want to do that. And then it's just like, why am I here? I really like that some people enjoy it. Mhm. That's what I'm signed up for this year. But I don't think anyone's gonna. Work was fun. I kind of want to do a GeoGuessr instead because that's fun.
It sounds like something like it sounds like a sport.
It's like online quizzes.
Yeah, so it's like.
So it might give you a map of something. Be like, name all the countries on this map.
I want to do that.
Hey, that's fun. Oh, I love geography.
Where you like show a picture of like movie stars.
Yeah.
Oh, that's cool.
It's my Wellness Wednesday activity.
Oh, that's yours? You have a good.
I stole it from Mr. Campbell. Campbell. No, one year the day before the AP test, we just played GeoGuessr the whole time because everyone was in a different AP test, and the like 3 kids, I think I had 5 kids in there, and they were all gonna get 5s. Like I knew they were, so I was like, "Well, you guys don't need to study. What do you want to do?" They're like, "Can we play GeoGuessr on the board?" I was like, "Sure." No, this was a long time ago. There was an Odegaard that graduated relatively recently. Her older brother, Tanner. It was my first year teaching BC. 20 seconds.
Oh, no.
Yeah, they like all got
I
5.
get tired sometimes. and like, get
No, one of them, like if I needed to check my work, I went to him. Partially because we thought about math differently. So if we got the same answer, that was going to be the answer. All right, I promise the next few questions are easier. Noah, we're running late. All right, I'm going to start going so you can decide whether you want to pay attention or not. I'm going to tell you the last class of functions that you want to choose for you are what I would call things that cycle. What I mean by that is things that when I take the derivative, it looks either exactly the same or very, very similar. Can you think of something that when you take the derivative, it looks exactly the same or very, very similar? E to the x is a good example. What's something like that in this question? Sine and cosine. So thinking about, remember how when we talked about the x, it was advantageous to choose x as our u because when I took the derivative, it was just dx, so it eliminated that product. If I have something where the derivative kind of looks almost exactly the same, that back end integral is not going to look any better. It's going to look very much the same. So we want to avoid choosing those as our u. We're never going to choose those as our u unless we're literally forced to, and you won't be in this class. The question that I think is really, really cool is what happens if both of those are together? Essentially, the back end integral never looks better, and you have to do something really, really funky, which is very, very cool. But we're not going to, that's outside the scope of this class. All right. So if we don't want to choose sine x as our u, what do you think we should choose as our u? Beautiful. That makes dv what? With my dx. That's good. So running through our methods, first thing we're going to want to choose is things we can't integrate. I can integrate both of these things. Second thing I'm going to want to choose is anything polynomial in nature. So the x squared is better than the sine x. Last thing I ever want to choose is something whose derivative looks exactly like e does. Like e to the x or sine. We're just going to go sine, cosine, negative cosine. All right, so what's du in this case? Okay, what's v? Good, thank you for remembering the negative. All right, let's roll, not with an integral sign. How does this go? U v. So x squared. I would like you take that negative. Don't write it like this anymore. Tired of seeing that. That looks like subtraction. Not parentheses. Do this. You can if you want to do parentheses. That's fine. All right. U v minus the integral of v du. You guys cool if I take the negative from the cosine and make this plus? Why is Aiden running down the hall? Aiden. The sophomore.
Or is it Mohammed?
Yeah,
We love him using our computer method.
he's on academic team.
Okay, Miss, I think he pretends not to know me because I know he knows my name, and he literally will talk to me in computer math. But then if I see him in the hallway and I'm like, "Hey, Aiden," he just like ignores me.
Okay. Does this look better? All right. I'd argue it kind of looks better. It got a little simpler. Instead of an x squared and a trig function, I have a trig function and just an x. But is it still a product? So what do you think we're gonna do? Again, just like Yusuf, just like L'Hopital, just like all of our favorite methods, if we need to use it again, we use it again. Yeah, essentially here, if we're choosing polynomials as our u, the goal is to get rid of the product. I want to get it down. So you may be thinking, well, what if that's like x to the fourth? Am I going to have to do this a bunch of times? The answer to that would be yes. I'm going to show you a method where you can shortcut some of that. We've been chatting so much. I don't think we're getting to the notes check today, but whatever. No, I know you guys are really upset. We'll start with it next time. So help me out. What's u? Yeah, we want to continue with that kind of choice, kind of like Nina's saying, we want to get rid of that product. And in this step, we will. What does that make dv? Ma'am.
Are you just doing it for the stuff inside the integral?
Yes, that's a very good question. I am now just focusing on this back end integral and kind of like we talked about before, that first term just along for the party. Yes. Mm-hmm.
Like, why do we make it?
Because we're assuming that it's like a derivative already. It's just the way integration by parts works. Mm-hmm. It's kind of coming from our formula, if you will. I know it's not really a satisfactory answer, but all right, du 2dx v. All right, so along for the party is negative x squared cosine x. Now, I do want to do the integration by parts. If you don't like that we use different u's and v's, you could certainly use two different letters if you're notation happy. But I'm going to do u v, so 2x sine x minus the integral of v du. Check me, make sure I'm good. What? Yeah.
We have to keep going.
So that's a good question. So, Kat, what's up? Yes, you could. All right. my question to you, will we have to do integration by parts again? Victoria's giving me a strong head shake, and she is correct. We now only have one function inside here that has an x in it. And like Kat just mentioned, we could take this 2 and shove it out in front of our integral if we wanted to. So our only final step is just to integrate this last guy. So along for the party is x squared cosine x. Along for the party now is 2x sine x. And then let's focus on sine. What's the integral of sine? Negative cosine. So I'm going to change this minus into a plus, bring the 2 out front. And I finished all of my integrating, so now plus c is also at the 4-term party. So this question would be very, very annoying if that x squared were maybe an x cubed and x to the 4th. I'm just going to have to keep doing this. So I'm actually going to skip this one for a second. And I'm going to go down and do this last question really quick. And I'm going to have you guys finish by doing natural log of x. But some of you are noticing that this is why this question would get really, really annoying. That e and that sine, they're not going to simplify as they keep going. So you're going to keep wrapping around, and it could go on forever. The way you fix that is very cool. If anyone's interested, I can show it to you if we have an extra minute in class. The 4 terms that we had. Boop, boop, boop. Well, the c is a term. He's not that interesting. All right, so I want to show you a method. If you did not like the fact that this was a lot of writing, I want to show you an alternate way to do this called tabular method. This works very well if you notice you're going to have to do integration by parts more than once. So this is on the very back. This is a completely optional thing, but very cool if you have to do integration by parts twice. Also cool if during that integration by parts, you're going to have to keep track of some sort of like U sub or chain rule situation. So I'd like to show you this in tabular, meaning it's a table. Let's label our table together. Label our table. What? Derivatives of U integrals. All right. So again, I might think about using this. You don't have to. This is just an alternate version of what we just did. You're probably only going to want to use this if you have the situation where you've got like an x squared, you know you're choosing as your u, and that derivative is eventually going to go to 0. So don't use this for the e to the x sine x thing where it cycles forever. You need something polynomial you're choosing as your u. What u do you think I'm choosing? Kind of just said it, but whatever. X squared. All right. So we're going to start by taking that x squared, and we're going to take its derivative until we get to 0. So first derivative, 2x. Next derivative, 2. Next derivative, 0. Now, you know how the formula goes uv minus the integral of v du? And then if we were subtracting, the next integration by parts would be like uv minus the integral of v du, but that minus would be in parentheses. We'd have to distribute. So for all of these terms, we're going to actually alternate in signs, and we're going to keep track of that in its own column. So we're going to start with positive because it starts with uv and then minus v du. But if we minus that second minus, that would go alternate. All right, what would dv be in this case then? All right, I'm actually going to keep the dx off because we're not really keeping track of all of the nitty gritty of the notation because we're using this table to organize. All right, getting from dv to v, we will have to take an integral. What is this 4x going to do to that integral is the question. Kind of a chain rule. So chain rule would be if it were a derivative, we would multiply by 4, right? If we were doing an integral, we would kind of want a u sub this. And I think what that's going to do is it's really just going to chuck a 1/4 out in front of that integral. Anyone kind of see what I'm saying by that? This is the kind of U-sub where I'm like, if you're starting to feel comfortable here, I don't need to see this work. This is just going to chuck a 1/4 out in front because 4x, I just need to keep back the idea of that chain rule in mind. So I'm going to put a 1/4 here and just integrate like normal. So the integral of sine is negative cosine, and I still have this 4x. I'm going to integrate again, and that's going to chuck another 1/4 out front. So instead of 1/4, I'll have 1/4 times 1/4, or 1/16. Integral of cosine is regular sine, so that negative will stay. All right, let's see who's been listening and who kind of understands. What? So integral of cosine is regular sine, so the sign won't change as we go. The SIGN won't change. All right, what do we think the next one's going to be? Yep. Perfect. No negative because the integral of sine is negative cosine. All right. Now you guys remember how the integration by parts formula went? It went UV. So we're going to take the positive. We're going to go to U. But remember, this was dV, so we're going to go down. We're going to go this way. We're going to go down. I'm going to draw all my arrows, and I'm going to show you how they work. This way. I'm going to go down. And this way. All right. So my first term, I'm going to follow the red arrow. I have positive x squared times negative 1/4 cosine 4x. That's our UV. We can kind of see where that's coming from. Our next term, we're going to follow what I have as the orange arrow. I have minus 2x, negative 1/16 sine 4x. Next term, positive 2 times 1/64 cosine 4x. I know it's a lot to write, but let's look at what happens once I get to the green arrow. What do you notice about following that green arrow? 0. What's the next derivative down? If I followed rainbows, what would the blue in the middle column be? What's the derivative of 0? 0. And so every single other term after this is going to be 0. So I'm only getting these 3 terms out of it. I slap on my plus z and I am done. Yeah, I could simplify a little bit. So this is probably how I would. Feel free to copy down or don't if you don't like simplifying. I'm just simplifying the fractions out in front. So this is a really good method if you are doing integration by parts more than once. I would say it's a little bit overkill if you're only doing by parts once because it's kind of the same amount of work. It also really helps, I find it helps when you've got to keep track of this kind of U-sub stuff and you've got a lot of fractions happening. It can be a little advantageous there. Yeah, for sure. What did I do? The right column of the table. So I found what my dV was. You agree with my sine 4x? All right. Then that was just integrating every single time. The 1/4, 1/16, 1/64, kind of like a reverse chain rule here. Since I have the 4x, if I had integrated like off to the side, my u would have been 4x, my du would have been 4dx. I don't have the 4, so I would have 1/4 every single time. So you could, if that had been like x cubed, it also would have worked. I can do 3, 4, 5, as long as you have that polynomial term that you want to act as u. The only time it really doesn't work is with a question that's like this. We tried to make it work one year. It's really complicated, but this is outside of the scope. Yeah, Ashley.
Oh, would this work for one?
Yes. So this would be a good example of a question that it would work for. So if you liked that table better than doing this twice, yeah. All right. So can I get your ears for a second? I think these dates are wrong now. Are these dates wrong? Yes, because it's the 11th. All right. So just so you know, let me see if I can get my table going. All right. I'm going to fix those dates that are on our OneNote in a second. Shut up. Yeah, well, it snowed. All right, so let me just give you guys a little bit of information before we leave. I need you to stop talking. So we have 3 more lessons in Unit 6. They are partial fractions, which is algebra heavy, but not necessarily hard, just long. Trig integrals, which is going to be everyone's super duper favorite because I know how much we love trig. And then improper integrals, which is we are going to integrate when infinity is a bound or when we integrate over a space that has a vertical asymptote in it. Very cool. I will tell you those notes are going to take a while every class, but try to bring your problem set. If we have any extra time, we will do that. We'll probably open with this class's notes check next class because partial fractions won't take too long. Our test, while it is currently scheduled for next week, remember, regardless of when it happens, it will not go on second quarter. So if you're focusing on tests right now, I would think anyone who has to make up a test, let's start coming up with a plan. Reassessments, I would like those done by Friday. If you need a slight extension on that, start talking to me. If I haven't heard from you by Friday, I'm going to assume you're done. That's it. Bye. Thank you guys. It'll be due whatever day this ends up being, the 7.1 day. I'll have Rashad, I'll make sure I have the right dates by next time. Bye guys. Bye.
Possible to schedule another date for Unit 4.
Yeah.
But like,
Just shoot me an email with what you're thinking.
yeah, because I don't think I could do it this week. I have college stuff.
Yeah, I know with the snow, it made it a little bit hard. So ideally it'll happen sometime either this week or next week. I think that's as far as I really want to push
So
it.
I can just email you about it.
Yeah, just let's start the conversation and get a date on the book so we can kind of have a plan going through.
Okay, thank you.
Perfect.
Can I do the same thing, but
Yeah.
I can get you my corrections by Thursday.
That sounds great. Yeah,
Okay.
just shoot me an email so I know what kind of our plan is.
Okay. Do you
I
have
know
any particular days the next?
what block are you thinking? Or before school, after school, what are you thinking?
I can do either.
All right, just let me know what you're thinking. I
Okay.
can do after school on Mondays and Wednesdays is really easy because I have academic team.
Okay.
Before school's always easy, though might be a little weird with timing.
Yeah.
And then I have 4th and 8th planning. If you have like an early release, that's also really easy, but I can try to make anything
All
work.
right. Yeah, I'll email you.
Perfect.
All right,
Sounds
thank you.
great.
Bye.
It's going to be pretty late because we're going to Rock Ridge and they are making me work the match that we're not playing in. If you do you drive yourself? Okay. So it's going to be pretty late. My guess would be like probably get back here definitely in the 8 o'clock hour, if not closer to 9.
I have a thing at like 7:45.
Then I would skip out because we probably won't be back by then. Don't worry, because both the teams are 0 and 6, so we're gonna win anyway.
And also, what's the trick to the cycle?
So I don't want to tell you. You end up having to know what your original problem was. It's very vague. I'm gonna let you ponder on it. I think you might be clever enough to figure it out. Did they mess with your dates again?
No, I have to update it. I have an update.
I always get scared, Max. The academic team likes to change dates.